Hello, this is Mr. Rasmussen, and welcome to Algebra 1, Lesson 81. This lesson introduces consistent equations, inconsistent equations, and dependent equations. We can find out whether they are which of the three by graphing. Consistent equations, when graphed, will produce two lines that cross each other. Inconsistent equations, when graphed, will produce lines that never cross, run parallel, and dependent equations, when graphed, will produce two lines that are directly on top of each other. We can also find out if two equations are one of the three by using substitution or elimination. When consistent equations are solved this way, you'll get a set of coordinates. For example, x is 4 and y is 3. When you use this for inconsistent equations, you will get two coordinates that are not true, such as 2 equals 1. You get two numbers that is an untrue solution. And dependent, when you solve it using substitution or elimination, you'll get a statement that is true, such as 5 equals 5. So let's look at the first one here. I have an example of consistent equations. You see my two equations at the top here, and it's already in intercept slope form. So as graphing these, my intercept is 5, which is right here. My slope is negative, so it's going to go down, and it's an understood 1 over 1, a rise of 1, and a run of 1. So here we go down 1, over 1, down 1, and you can see where that line is graphed. My second equation has an intercept of 1. So there that is. It has a positive slope, meaning it goes up, and also 1 over 1. So it goes up 1 over 1, and here that's graphed. And we can see that they cross there at coordinates x2 and y3. So these are consistent equations because they cross. Let's look at how that would look if we were to use substitution and elimination. So once again, here's my two equations. And if I take this part, which is equal to y, and substitute in for y, here it is at the top. I'm going to subtract a 1 from both sides to eliminate it from that side. It gives me x equals negative x plus 4. I'm going to add an x both sides to eliminate it here. That gives me 2x equals 4. And then divide both sides by 2, and I get x equals 2, which is the same as we saw for graphing. Take that 2, plug it back in to my equation here, and I see that y now is equal to 3. And now I've got the same solution set showing me that it is consistent equations. If we were to use elimination, in this case here, if we take our initial two equations, it's already set up where if we add them, we get 2y, the x's cancel each other, 5 plus 1 is equal to 6, divide by 2 to get the y by itself, and we get y equals 3, and then you'd probably use substitution to put that back in. I did do that here to show what it looks like if we wanted to eliminate the y and solve it for x. If we were to multiply the top by a negative, we'd get negative y equals x minus 5, and we add those, the y's cancel, we get 0, 2x minus 4, add a 4 to both sides, 4 equals 2x, divide by 2, once again, x equals 2, giving us our solution set of 2, 3, meaning that it is consistent equations. They do cross each other. Let's take a look at inconsistent equations. Inconsistent equations is where if you were to graph it, the lines run parallel, they never cross each other. So this is already in slope-intercept form. I have an intercept of plus 2. So I have a negative slope of 1 over 1. So you can see down 1 over 1, and there's that graphed. My second equation is negative 3 as an intercept right there. Same slope, down over, and you can see that these lines will never cross. Therefore, there's not an x value and a y value, a set of coordinates that both of them will ever share. So let's see what that looks like if we were to solve it with substitution and elimination. Here's substitution. I'll take my bottom part, which is equal to y, put it in for y. So there it is. Negative x minus 3 equals negative x plus 2. Let's eliminate the x from this side. And when I do so, the x's totally goes away, and I get negative 3 equals 2, which is an invalid statement. It's not true, therefore proving that it is inconsistent equations. There's no x coordinate that they both share. Let's look at elimination just for practice here. Here's my two equations. If I were to multiply the top by negative 1, then it changes it to this here. And then if I add them together, my y and my negative y give me 0. Same thing for the x. Negative 3 and negative 2 give me 5. Gives me a statement that is not true, showing that it is inconsistent. An easier way perhaps to look at that and know from the equations, if I come back here to this one and look at my two equations, very simply, if they have the exact same slope, negative 1 over 1, negative 1 over 1, and they have different intercepts, it's going to be inconsistent because the slope is the same, but they don't start at the same points. All right, lastly, let's look at dependent equations. Dependent equation means that if you were to graph them, they graph right on top of each other. So I've got my two equations here. In this case, my second one is not fully in slope-intercept form yet because y is not by itself. If I divide everything by 2, then y is by itself, and I get this. So my intercept is 2, and it's a positive slope of 1 over 1, and therefore it's graphed there. This here, same intercept, same slope. There's your indication in the equation on whether it's dependent. If they have the same slope and the same intercept, they are the same exact line when graphed. Let's look at it for substitution, just for exercise sake. Here's substitution. If I take this part, which equals y, put it in for y here, I have it there. I need to remove my parentheses, so 2 gets multiplied in to be 2x plus 4. Let's subtract 4 from both sides, and I notice that cancels the 4's all the way out. I'm left with 2x and 2x. Let's subtract 2x from the one side, gives me 0, but it goes to 0. Subtraction from the other side, I get 0 equals 0, and an indication, something that is a true statement, but an indication that I have no coordinates. Actually, they share all the coordinates. Every x coordinate and y coordinate together is valid for both of them because they're the same line. Okay, as we continue here, I'm going to work through the 3 practice problems in the lesson, and you can do them, pause the video if you'd like, and do them yourself, and then check it with my work, or if you need the instruction, then just follow along with the steps as I do it here in the video. Our first equation is y equals x minus 1, so I'm going to go with my intercept, which is negative 1 right here, and then my slope is positive, and it's a positive 1 over 1, so such as this, up 1 over 1. Let me complete that line there. Line that up. There we go. All right, something such as that. Okay, and then we're going to graph our second one here. The whole goal of this is to find if they're consistent, inconsistent, or dependent, and then in this case, if they are consistent, to give the solution set, or to give the 2 sets of coordinates, the x value and the y value. So in this case, I know that it is going to be consistent because my slopes are not the same, and so my intercept is going to be plus 5. So here's plus 5. My slope is negative, which means it's going to go down, and it is a negative slope, a rise of 2 and a run of 1. So a rise of 2, come down 2 over 1, down 2 over 1, and we see we're across another line. let's put that in there. There's my other line, and we can see that they do cross. It's going to cross at x equals 2, y equals 1, and so a 2, 1 is my answer for that. Just for academic sake here, let's use substitution and confirm that that is true. So down here, here's my two equations. Let's put substitution, so I'll take this guy and substitute him in for y. So x minus 1 equals negative 2x plus 5. All right, let's add 1 to both sides, giving me x equals negative 2x plus 6. And then let's remove the x from this side. Plus 2x to both sides gives me 3x equals 6. And if I divide both sides by 3, now x is equal to 2. Confirm that that is true. If I substitute it back in, 2 minus 1 is 1. And there we go. We have a correct answer for practice problem A. Well, let's look at practice problem B. Practice problem B is already in slope-intercept form. When you see it this way, this one here actually has an intercept of 0 if nothing's written there. So let's graph that one first. My intercept is 0, so start right here. And then I have a positive slope. It's going to go up and 1 over 1. So up 1 over 1, up 1 over 1. And let's get that line put in there with my straight edge. All right, there's graphed the first equation. Second equation is simply y is equal to 4, which means x is equal to all of them. So y is equal to 4, no matter what x is. So basically like that. And let's put that line in there, which is a horizontal line across the paper. And so I see they cross right here. They are consistent equations because they don't have the same slope. And my coordinates are going to be x equals 4, y equals 4, so 4, 4 as my coordinates for those as a consistent equations. Let's use substitution just for academic sake. Really simple here. Y is equal to 4, so if we plug it in, 4 equals x, and there we go, 4 and 4. Okay, let's look at our last practice problem. And hopefully this is pretty simple for you as far as what the consistent, inconsistent, and dependent equations are. This last one here gives us two equations, and it asks us which of the three are they? Are they consistent, inconsistent, or dependent? So these are actually not in slope-intercept form, so let's change them to slope-intercept form first. Y equals, I'm going to move the x over, so I get negative x plus 7. And then this one here, move my x over, y is equal to, subtract it from both sides, negative x plus 9. So already we can see that we have the same slope, which tells me that they are not consistent. It tells me they're either inconsistent or dependent. Do they have the same intercept? They do not. So it is not dependent. These are consistent, or rather, these are inconsistent equations. Inconsistent equations are two lines that run parallel to each other and never cross. Let's graph this just to show that by graphing. Our intercept for this one is plus 7 right there. It's a negative slope, 1 over 1. So it goes like that. And I'll draw that line in there. Okay, and then our second equation has an intercept of plus 9, so slope is negative and 1 over 1. And so that one is the same slope, runs parallel to it, henceforth they have no set of coordinates that they will both share. And it is inconsistent equations. Once again, just for practice with substitution, I have them down here. Let's show that that is true through that. When it's substitution, remember it's inconsistent. It's going to give you two numbers that are equal to each other. That's not a true statement. So let's rewrite this since This one is equal to that. Let's write it out as negative x plus 7 is equal to negative x plus 9. All right, what we're going to do here, let's add an x to both sides. As you can see, that cancels here and cancels here, and we get 7 equals 9, and it is not a true statement. Henceforth, it is inconsistent. So if you have any questions about this, please feel free to contact me through my cell phone, through a text, or a call during school hours, and we'll work it out. Have a great day.